So in this video, we're going to look at it's called the difference quotient. And so we're trying to kind of find a formula for average rate of change that this is really kind of how calculus spawned. And so what we're doing is I drew a graph here. It's a cubic graph, and I've got 2 points that are on the graph. And so what I'm doing is I'm making this point on the right kind of move around, and we want to look at the average rate of change between these 2 points on the graph. So here they're nice integer values between on this graph. But what eventually we want to do is come up with a formula so that as this thing gets super close to -4, 0, what's the slope of that line? So right now we have a secant line that touches this curve at 2 points. And what I want to say is, well, what if I got this super duper close so that now it's a tangent line where it just crosses here? What would the slope of that tangent line be? And that's really what the beginning of calculus is, and really the essence behind all of calculus. So let's take a peek at this. We're going to do this a little bit more abstractly, just using like x's and y's. And so let's just kind of take a peek at what I'm talking about here. I'm going to just draw some random curve here. There's my little curve. And what I'm looking for is I want to find, we'll just call this point x, y. And so on this graph, I'm going to go over some amount in the x direction. We'll call that h. And when I go over h, this graph is going to change some way in the y direction. So it's going to go up or down some y value, and you're going to have this new point. And so I think we'll call the first point x1, y1. And the second point we'll call x2, y2. That's a 2 there, believe it or not. And so the difference quotient, let me type it out so it's a little bit less messy than my penmanship. Quotient, there we go. What we're doing is we're kind of looking at the slope here between these 2 points. And so the average rate of change is what we called it before. The average rate of change and I'm actually going to change this up a little bit, which, you know, I'm sorry for waffling here, but I'm doing this for a reason because I'm trying to tie it into stuff that we know from before. So we're going to call this x1, and then we're going to use function notation, so it's going to be f of x1. And then we're going to call this x2 and f of x2, and we're going to change it again later, but we'll just kind of baby step our way through it. So that's our coordinates of these 2 points here. So the average rate of change is going to be the change in y over the change in x, like we saw earlier. Change in y over change in x. And so the change in y is going to be f of x2 minus f of x1. Over x2 minus x1. Well, guess what? The change in x is actually, we're going to call that h. And so I don't like this bottom here. I'm going to mix it up. I'm just going to call it h. So we'll kind of keep the top the same for now. F of x2 minus f of x1. And then over h. So we're just trying to kind of simplify. It may make it look a little more confusing here, but the x change we're just going to call h. So instead of saying x2 minus x1, we're just rewriting that as h. Well, the other thing I've noticed is h if we go from x1 over h, we end up at x2. So that means if I go x1 plus h, I will end up at x2. So x2 I could replace with this expression here. So instead of f of x2, I'm going to rewrite this as f of x1 plus h minus f of x1 all over h. And the difference quotient here is really, I'm going to get rid of this one here and this one here. So really what it is if you have a point, well, this one right here, x1 f of x1, or just x f of x, we don't really need the x1 because we don't really care about what the other point is. If we have this point right here, and we just move over some amount h, h can vary, it can change. So if h is 1, then you'd put 1 in here. If h is 2, you'd put 2 in here. And so what we want to look at here down the line is what's going to happen as h changes, and that's really what calculus is all about. And as h gets really, really close to 0 is really the important part that will be coming up. So let's take a look. Let's just look at a random quadratic. So we'll say y equals 2x squared plus x minus 4. So I want to come up with a formula using the difference quotient where I can find a bunch of average rate of change by just plugging stuff in for h. So if I draw this out, it's going to be a parabola of some sort. It's going to look something like this. And I'll just pick any random point on here. We'll call it x, f of x. So there's our point. And then we're just going to move over h. So our difference quotient, we'll call it dq, not ice cream, is going to be f of x plus h minus f of x all over h. And so f of x is 2x squared plus x minus 4. So I shouldn't have written this as y. I probably should have written it as f of x. Try to get in the habit of doing function notation here. And so the difference quotient, the way we plug this in is I'm just going to I'm going to kind of give myself some room here. Woo. And so it's going to be minus f of x, which is 2x squared plus x minus 4. And then f of x plus h is f of x, but everywhere you see an x, you put an x plus h. So it's going to be 2 and then x plus h squared plus x plus h minus 4. And it's minus f of x, so all of this is being subtracted, not just the 2x squared, so we got to be careful there. And then all over h. I'm really sorry about my penmanship here so far. Try to clean it up here in a second. So we want to simplify this a little bit. This is quite a mess, and it's going to simplify pretty nicely. First, I'm going to square this x plus h. So I'm going to do this next step in blue. We'll have 2 and then times x plus h squared is x squared plus 2xh plus h squared. And then this is just plus x plus h minus 4, and then minus 2x squared minus x. The reason it's minus x is I'm distributing this negative sign here, and then plus 4. Plus 4. All of that, let's see if I can do a straight line. Of course not. over h. Okay, and so I'll distribute my 2. I'm going to try to get this a little bit cleaned up here. So we get 2x squared plus 4xh plus 2h squared plus x plus h minus 4 minus 2x squared minus x plus 4, all of this over h. So let's look at the top if there's stuff that we can cancel out. Nicely, there is. I see, let's grab a green color. I see there's a 2x squared, whoopsie, and a negative 2x squared. I see there is a plus x and a minus x. I see there's a minus 4 and a plus 4. So what's left is 4xh on top plus 2h squared plus h, and then on bottom there's just this h. And remember, h is just how far over in the x direction it's changing. So h could be anything if it goes over 1, over 2, over 0.1, over 0.0001, whatever the case may be. So we end up with, let's see, 4xh plus 2h squared plus h all over h. And so I notice I can cancel out an h so that it ends up being just 4x plus 2h plus 1. And so this is our expression we can use for the difference quotient. So if I pick a point on that curve, we'll just say some, you can pick any point, and then if h is, you can kind of make a table here. If h is 1 and you have a point on that curve, you just put 1 in there and you put an x value. So let's say I'm going to say if h is 1 and x is 2. What I can do is find out how much it has changed. So we'd have 4 times 2 is 8, plus 2 times 1, which is 2, so 8 plus 2 is 1, plus 1 is 11. So our difference quotient tells us that if we're at 2, if x is 2, and we move over 1 on our graph, that we're going to have a change of y as 11. So our slope from at x equals 2, our change in y is going to equal 11. And that's kind of what our difference quotient tells us. So if we look at the graph, I have the graph pulled up here. Here's the graph of 2x squared plus x minus 11. If we look at an x value of 2, the y value is negative 1. And so then if we go over 1, so our x value is 3, our y value is now 10. So from 2, negative 1 to 3, 10, the y value of the slope has changed 11 units. And so that's what this difference quotient tells us, that if we start at x equals 2 and we go over 1 between x equaling 2 and x equaling 3, the slope between those 2 points is going to be 11, or the average rate of change, technically, not the slope. So what we're going to do eventually is we're going to make this h value super small and see what is the average rate of change as this approaches 0. And that's kind of be what we're going to do next. So this is the introduction to the difference quotient. The whole main idea is f of x plus h minus f of x all over h. And then you plug stuff in for f of x plus h and f of x and simplify, and you'll have a nicer, cleaner formula to find quick average rate of changes on functions.